Hey everybody, we're back with the next part of the deep dive, and this part of the dive goes pretty deep. We've got a lot of videos that we include in this section to give you a little bit of depth for a lot of the topics that we normally sort of skim past a little bit. So let's get going here. This one, we're going to mostly think about sensors and sort of a deeper layer of thinking about inputs and outputs for the device. And we showed this a little bit last time, but this is a good graphic that shows the front and back of the microbit and some of the features that are included. This is a version 2. And so again, very similar to version 1, but includes of course, the connector, the USB connector, the logo that's now touch capacitive, an LED light array, buttons A and B, which can be A or B or A and B together. There's a microphone and a speaker. That's really the biggest upgrade that people were excited about. A radio antenna so that you can connect two or more microbits together. I think the processor has been upgraded. That you can turn the power off, which is great when you're on battery. There's the edge connector, and then there's a bunch more that we'll talk about. So we mentioned this in a previous session, but just to go back to it, there is a light sensor, and it actually uses the LED array for this, but you can use that to capture approximate light measurements. Again, it's best to think about this as sort of light versus dark rather than getting something that's super accurate. But you can use that, and then you can judge if it's sort of bright out and daytime, or a light is on or off, and do those sorts of things. And then again, use that either as more of a binary, like on or off, or a bright, medium, and dark, to trigger other events or to include in more of your code. There's a temperature sensor. The temperature is within the processor, and I think that it's basically in there to make sure that the processor doesn't overheat, but they're sort of doubling up on its use, and they are able to take that and provide that information to you. And so you can use that. Again, I would recommend thinking of it in a coarse way, COARSE, that it's hot or cold, or it's getting colder or getting warmer, rather than a specific value that would be like you might measure with a digital thermometer or something like that. So again, you could play with that and use that to as a sort of measurement that you could use, or that could be used in triggering some other event. Rotation and acceleration. There's accelerometer. I believe it's a 3-axis gyroscope that measures motion in 3D, 3 dimensions. And you can use this. It's quite accurate and quite sensitive. So depending on your use case, you'll need to sort of test it out and calibrate what motions you would want to use, what level of motion you would want to use to trigger an event or to capture. We've tried to use this with a digital egg drop before. We actually used the MicroBlocks coding platform for that, and it worked okay. But sometimes the drops were so great that it sort of went off scale, and then it acted as if it had not been dropped at all. So anyway, so it's important for you to think about what the values are going to do for you, and then make sure that whatever the activity you're using it for, or the range of forces or motions that you're trying to evaluate, will actually get measured, meaning that they sort of happen over a certain period, that the microbit can actually measure it, and that it's going to do the right things, meaning it's going to measure high as high, low as low, and that sort of stuff. So just like any of the sensors on this, really, and any of these microcontrollers or microcomputers, we'd recommend that. But particularly with this, where it's not what I consider sort of science grade or research grade measurements that you're getting here. They're pretty coarse measurements, but they can still be useful and still a lot of fun. And it's better to explore with these than it is to not do it at all. We also have some examples on here that you can check out. So many of those sensors can use something like a variable, where you can take that measurement and you can feed it into a variable. And that variable is basically a container that holds that information. And it makes it easier for you to then just use that variable later in other processing, like mathematical processing, or again, if then else type statements, where you don't need to put the actual specific value. You can use that variable. Sometimes the sensors essentially generate their own variable, like temperature, and then you can use temperature throughout. Other times you might want to create a variable like X or T, and then set that variable to the value that's being measured, and then go ahead and use your created variable throughout the rest of the text. So you can use it for numbers. You can use it for strings if you wanted. If you had a certain output that you wanted to give out every time something happens, you could use it in that way. Or you could have it as a true/false, so Boolean variable. So this is one way to help make your code more efficient, and to just generally make things easier. So just a little break here. We included some slides that we've used before. We're not going to ask you to do them, and I'm not going to really walk you through them, but these are slides that you could adjust and use with your students to get them to think about some of the different sensors, and thinking about things of like why they're used in certain ways, what questions they have, and ideas that they might have for their use. So we've got one for temperature, for light level, and for the compass, which we'll talk about a little bit later. And so again, you can feel free to use these and adjust them as appropriate, but it's just sort of a framework for getting them to start thinking about these sensors. So loops are a really useful sort of shorthand that you can use in coding, again, really toward making the code itself more efficient and economical. Sometimes as you try to use these, it creates challenges and unforeseen challenges. But generally speaking, if you can break your code into things where loops could be used, then I think of it as you're just going to have to focus on that single loop and get it to work as a smaller block than if you had to try to repeat it multiple times. And sometimes it's not equivalent. So it's not always equivalent to have a loop that says repeat something 4 times and then to just copy and paste and have that thing repeat itself 4 times. So sometimes the behavior there is not always the same, and that's, again, something to watch out for. But generally speaking, when you can use a loop, or if you can use a loop, I'd recommend that you try to use a loop. And so you can use something that will tell you how to repeat or how many times you want to repeat a certain set of code. So say for a music or for a light pattern, you might lay that out, and then you could say repeat that 3 times, and it's going to go from top to bottom through that code, and then go back to the top, repeat it again, and go back to the top and repeat it again, depending on how many times you've asked it to repeat. So there's a while block, and what that basically means is while one thing is true or is not true, then sort of run the rest of this code. But if the depending on how you set it up, if this is true or is not true, then you might go in a different direction. So in this case, we have while not button A pressed. So sort of anything else, then repeat 2 times these tones or these sounds. So when button A is pressed, then it would do something different. Okay, so again, sometimes that can get a little tricky as you're thinking about it, but it gives you some flexibility in how you're going to use it. So here we have the loop block is useful when you want to program your loop until a certain event happens or a different condition is met. So this might be useful. We're going to ask you to create some games. So this could be useful where, sort of while the object, the game object, the sprite has not been hit or intersected with something else or hit a wall, then you can keep adding score. But as soon as it hits a wall, right, then it's going to trigger some other event. And then there's a sort of a for block, okay, and then you can indicate that for a certain event, and then you could sort of set a the for loop is probably best used, and we're talking about not the forever block there, but the for loop that's inside of that. That it's probably best set up for if you think about sort of a range of occurrences to occur. So when a certain variable or a certain event happens, and then you want something to run a certain number of times within that range, then this is a good loop you can use there. And here we have, and you get an extra bonus where Barbara put together a brief video to talk a little bit more in depth about loops. And so you can watch that and get a bit more information and ideas about how you might use them. Next, we wanted to try to present a couple new things. I think most of those things that we just talked about are things that you've sort of seen before or we've talked about before. But now we want to talk about a couple new things that might add to your toolkit. So we did touch on this in some previous sessions we ran, but just in case you missed that, the microbit itself, when it scrolls text across the screen, the default is often relatively slow. And especially we have found that when kids are trying to use this and they want to send a long message across, if it's in that default speed, it goes quite slowly and they get frustrated. And by the end of the time that the text is going across the screen, they've sort of forgotten what came before it, and it's not doing what it's meant to do. So with this, you need to toggle from the blocks into JavaScript or into Python, but then it's a simple change. And so you can see on the left here that when you see the string of text, and you can see sort of both versions of it here. So in the upper right, you see the block, right? Forever show string hello. So what that's going to do is just keep repeating hello over and over again. You see what that looks like in the text block or the coding block sort of down to the left. And all we're doing to change the speed is putting a comma after the text in quotations, and then adding a number. And you can go, I think you can go down towards 0 and you can go up to maybe 300 or more. And you can play with that number and it will give you a variety of speeds. Some will be very, very fast and some will be very, very slow. And I think it's as you get closer to 0, I believe the speed gets faster, but I'm not 100% sure about that. But go ahead and play with that. And again, that's something that you can mess around with depending on the length of your text and probably the age of your audience too. I would imagine younger gamers and things can sort of pay attention to that and follow it a little bit better than, say, older adults who might be playing with it. Okay, so we're going to jump into some more sensors here. So one of the ones that was added is the ability to record sound. There's a small microphone on the microbit, and there's a little indicator on the face so that when you have turned the microphone on, that will turn red so you know that it's recording. So I will let you play with this. We do include an example. Just beware the audio is not a fantastic audio recorder like your phone or maybe your computer or microphone would be that you have for your studio, but it does record, and so you can use it and you can then play that sound back. And so go ahead and explore that. There is using the magnetometer in the same location as the accelerometer. You can use the microbit as a compass, or you can use compass functions. This is pretty cool, and we have some examples on here of what that looks like and how you could code for that. You should be aware that you should calibrate the compass every time you use it. Just because it is sensitive to metal and it's sensitive to sort of where it is, that it is really helpful to calibrate it. So usually you would do that as an on-start setup to calibrate. And then the default, my understanding at least from playing with it, is the default is that it gives you sort of within 360 degrees. The reading that would come out of there is the heading with 0 at north, and up to 360 would be north again. And so again, you can look at some of the examples there and play with it. One thing that is pretty neat that I haven't done myself, but I think is a pretty cool use of this, is that you could potentially use this as a metal detector because of its sensitivity. That if you had magnetic materials in the area, you could use it and its sensitivity to that to notice changes in the magnetic field and then see what you can detect. Another cool feature that was added is the capacitive touch sensor. And just like capacitive touch on many of the phones, if and when you get your finger, probably not in a glove, near the logo that's highlighted in the top there, it will cause a change in the electrical field that's around that, and then that can be used to trigger events. It will tell whether it is touched, pressed, released, or long pressed. And all of those can trigger different things. But again, I recommend that you test this out, or any code you produce, to make sure that it's going to work the way you want. One of the other things that we wanted to talk about is the potential to go beyond the single microbit board that you have. So we're going to explore a couple of those opportunities next. There are a few different ways that this can happen. And so one of them is to go beyond the single board using the pins that are at the bottom of the board, or the edge connector as it's called. And you can use that to connect to various wires, servos, lights, other sensors, and things like that. The other one is what we have as send it. So there's a radio feature in the microbit where it can connect with other microbits, push out and pull in information from those. And so that's another way you can extend it. And then the other one is we're calling connect it, which is to use a variety of breakout boards that help to use the edge connector to then connect with other peripherals, to connect to servo motors and those sorts of things. Sometimes it can offer extra power. Back for version 1, it could offer a speaker. And so those breakout boards are pretty common. You might have interacted with them if you've used the microbit with a robotics kit or anything like that before, but we'll sort of explain a little bit of those. So one of the ways the board can be extended is connecting through servo motors. So we've got a little video showing an example of this coming up next, but basically for this context, servos are going to be generally small motors that can operate, and there's a variety of different operations. They can typically go 0 to 180, maybe 270 or 360. and sometimes it's just sort of a single motion at a time or continuous motion as they go through there. So it's best to think of them as simple motors, but often not the type of round DC motor that you might use to power wheels for a car or something like that. There's often 3 wires, and so you can use those to connect. We have sent a servo that would connect with the 3 wires. The issue is the servo that we sent, it requires a little bit too much power. And so most likely what you would get from your microbit if you try to power it directly is some grunting and groaning of it trying to move without much movement. So it's a good lesson in the sense that when you're buying servos to go along with your microbits, you want to make sure that they will work appropriately, or you can get an additional battery pack or something like that to add extra power, or you can use a breakout board, which we'll talk about in a little bit. Another way you can extend the board is connecting to different things like LEDs, copper tape, other wires and things. And so we sent a group of LEDs, RGB LEDs to be specific. So not the single light LEDs that have the 2 legs, but a sequence of 5 LEDs that can be programmed to light up in different colors. So the microbit is powerful enough to light these up, but you need some specific code to connect to them in the right way. It's not as simple as just turning them on and off like you might for a regular LED, but these need a bit of information about what color they're supposed to turn on and that sort of thing. Whereas a regular single LED, frequently it would just be, it is whatever color it is, and you're sort of turning that pin on or off. So these have 3 wires, just like the servo, and so that's going to be power, ground, and then whatever pin you're sending the information from. So we've got some code examples here, and then on the next page we've got a video that gives you a little bit more information. So another way that the board can be extended is using radios. And we're going to do a little bit deeper dive into radios. So we're going to hold off on telling you exactly how that can be used right now. But radios are really neat. As I mentioned before, you can connect one microbit with another, or you can do many-to-many or one-to-many. And so that's pretty cool. And there's some games. We played a hide-and-seek game when I was doing a training before, where as the instructor, I sort of pushed out code to the other microbits that were on and listening and ready for it. And then they had to try to find my microbit throughout the process. So you can do a number of things like that. You can actually test signal strength and a variety of things. So we'll call that coming soon. The third way we mentioned to expand the board is through using breakout boards, or what are called shields. They're the same thing, but you might see either of those names used. These are ways that usually independent developers have created so that you can take your microbit. Often, in the case of the microbit, you're plugging your microbit into the breakout board or the shield. Sometimes with Arduinos or Raspberry Pi, you might literally plug some of the connectors into each other. This is similar, but you're usually sliding the microbit into sort of a receptacle. And then the board itself, what the creators have done is usually they're taking all those little pins on the bottom and they're wiring that out. So if you look at the gator bit at the bottom of this slide, you can see those sort of white spaces around the outer edge. That's basically taking the pins that are at the base of the microbit and wiring them out to each of those so that they're more easy for somebody to use for a variety of functions. So I'm not going to go into all of these. There's many more that aren't pictured here. These are just a couple examples. But if you search microbit and breakout board or microbit shield, you'll see a lot of them. A number of them, I would say, are for robotics. And then a number of them sort of fit into other categories like connecting with sensors, or perhaps, utilizing music or amplification or something like that. So they might be focused on sound. And then sometimes you'll find ones that are very sort of general purpose. So it might come with a speaker and an amplifier. It might give more power, and then it might also help run servos, with a higher power output to those. So you can shop around and find them. Generally, they're not too expensive, but if you needed to buy boards for an entire class set, then it might become a more expensive proposition. So one of the features that we'll talk about is not a hardware feature, but it's conditional statements. So you might know these by logic statements, conditionals, if then else, that sort of thing. And so basically, these are really useful in terms of channeling the flow of your program, or the inputs and the outputs, based on the conditions that you want to set up. So if you think of an if something happens, then do this thing. That's probably the best way to think about it, but they can definitely get more complex than that. And so you could say if A happens, then do X, but if B happens, then do Y. You can also add in multiple of those if then else statements, or else if, and you can nest these so that there are conditions sitting within conditions, so they can get quite complex if you need them to. So Boolean examples of this are really just true false. So there might be something that's on or off and there's no in between. Or if there's two conditions, right, it might be sort of true false that condition is, that a single condition is the state of the system. And then the if blocks get a bit more complex. And again, this is where you can create multiple if then else statements. And even within the if statement, you can both nest other statements within that. And then if you look at the two examples on the left here, you see that it says if my score is less than 10, then do one thing. If my score is perfect, then do something else. The my score is less than 10 in the top there, that shape can be replaced with multiple other blocks within there that can make that a pretty complex statement. So it could be sort of a compound. So in other words, it could say something like, if my score is less than 10 and my number of lives is greater than 3, and there's still time left on the clock, then do something. So you can make that pretty complex. This is another way to think about this. This is the if then else. And this is where you might have multiple things that you want to be considered by the system. It will go top to bottom through those. I think it's basically determining sort of statement by statement which is the true condition, and if that's the true condition, then it sort of acts on that. Okay, so this, and you see the plus at the bottom there. You can keep hitting that, and that will keep adding sort of different layers, so to speak. So you could keep adding in those different else or else if, which you see here. So this one has a if my score is less than 10, then change the score by 1. And then for the sort of next statement, it's if my score is perfect, then do this. Else if score is not perfect, right, then do something else. So anyway, you can figure this out. It's really pretty straightforward, but you can make these quite complex. You can add in comparisons. Sometimes you need to be careful about the types of comparison. So you cannot do something like that would be comparing strings with a numeric value, and vice versa. You can't do a numeric comparison for a string value. So you can't say if false is greater than true, right, then do something else. It will return an error there. So you just got to keep that in mind. And then sometimes you don't actually have something specific you want it to do based on that logic. You want it to randomly present something, right? So I had teachers who were trying to create a little sort of vocabulary game where they wanted the microbit to randomly present, let's say, one of 4 or 5 vocabulary words. And so in that, they had basically a set of those words, and it would randomly pick one of those words to present each time. So you can use the random. You can make, this example here is to create a dice roll, but you can use that in a variety of ways. Okay, so finally we get to the challenge for this part 2. And what we're going to ask you to do here is to try to come up with a game that would be fun to play and engaging. So if you think about the characteristics that games have, it can be really helpful to jot some ideas down of what characteristics different games that you like have, and then think about how you might incorporate those characteristics into any game that you create. So frequently you get sort of multiple chances, right? You don't just get to do it once and then you're done and you can't compete again. You might be able to, with each chance, you're trying to get faster and faster, right? That's often one way that you can compete. You can get further into the game. That's another way that you can get points, or you can capture things, right? So think about those elements of the games. You might make it a single player versus multiple player. But here we want you to brainstorm on that a little bit and think about what elements good games have and write those down. And then some of those might be elements that you can include into the game that we asked you to create. Some of them might be too complex or just might not make sense for the game that you want to create. But you can at least check back against that list to see how many of them make sense to incorporate in your game to make it more engaging or more exciting. So it's maybe a little bit ironic that we are not going to take a deep dive into the gaming functions that MakeCode has. You can create a game without those game functions, but similar to some of the extensions that I mentioned earlier, if you look in the game drawer in MakeCode, there are a number of functions there that might make your life easier and might make creating a game easier. So I list a bunch of those here on this slide, and I'm not going to go into all of them, but the idea is that you would explore those and you would see what they can do for you and see if you can use them in the game. What I'd recommend is probably starting with an idea of a game that you would want to create and something that's reasonable for the microbit. Draw that out, design that a little bit, write out what features you think it has, and then try to accomplish it rather than just going in and sort of building from scratch a game without much direction or an idea. So here's the particulars of the challenge. So you're going to use MakeCode. You can use something else if you want, but we recommend using MakeCode. And you're going to design and create your own game, and you're going to code it, and then we'll share those games with others. So like we said, think about what would be a fun game. Maybe write down some of those features there. If you don't play games at all or haven't played games, let us know, and we can help you think through some of those features. Then when you start creating the game, think about who is it for, what is it going to do, what's the main goal of the game, right? What's the objective, how are people going to live or die, how are they going to gain points and do that sort of thing. Write out your ideas and then think about the general flow of the game, right? So how does it start? How does somebody work through a turn or work through the game? And then what does finish look like? That they're, when their sprite hits the side of the board, it's over, or when they, do it too slowly, it's over, or something like that. So think about what gameplay will look like. After you've done some thinking, planning, and maybe a little bit of playing, go ahead and start thinking about coding the game and dive into coding the game. Think about what we've talked about in terms of all the different features that you could use in terms of inputs and outputs. You do not need to use all of them, but we recommend using a couple of them. Particularly people like to use, say, the buttons and the gyroscope. In here, you could use the microphone, but be creative in how you're thinking about that. And what we're hoping to do in the group is after you code the game and share a video where you explain the game, that we will have other people play it and give you some feedback. And then you can try to go back and revise it, and we can give you some feedback as well. So we'd strongly recommend doing this when you're working with your kids to do this, is rather than giving them just one chance to do this, they should do their own internal testing and try to work through the bugs in the system and the code, and then have others play it. And that can lead to both determining things that, that the creator of the game did not expect to happen, and they might ask those people who are playing it, what could be done to make it more fun. And those people could say, oh, you should get an extra life, or it's too hard, to do it in that amount of time. So you got to give me more time to do it, or something like that. And then they can try to incorporate that feedback in future iterations. So it's time to go for it. So just like we said, think about, the features of games, think about what you want in your game, think about how you would get that to happen. We're happy to help at any of these stages, and then go for it and try to code it and test it and see how you can make it better. And then when you share it, share a video that explains what you did and how the game is supposed to be played. And then we'll do our best to have everyone give each other feedback and try to revise those games. And and we'll go from there. So you can share your code. This is the link to the part 2 flip that we have for this. And thank you very much. I hope you have a great time with this. Really, if you're not having fun, then you should stop doing it. But the real idea is to learn and explore while having fun with this.